All right, here we want to find the foci and the equations of the asymptotes of negative x squared plus 8x plus 4y squared minus 40y plus 88 equals 0. All right, so this is just the written out form, right, of this hyperbola. All right, so what we're going to have to do is we're going to have to complete the square on this guy, right? So we got the x terms. We also have the y terms here. Okay, so the order doesn't really matter, but we notice that the x's are already grouped together and so are the y's, right? But we also notice, hey, wait a minute, this is a negative x squared, okay? So in order to complete the square properly, okay, we want to factor out that negative. Okay, so we'll take negative x squared minus 8x. Okay. Also, we want to factor out the 4 from each of these y terms, okay, because we want the coefficient of y squared to be 1. So we'll factor out that 4. So we get 4 times, in parentheses, y squared minus 10y. Okay. And then we'll subtract the 88 to the right side. Okay. So what we've done is we just factored out the negative from the x's. We factored out the 4 from the y's. And we brought or subtracted this 88 over to the right side by subtracting it. All right, now we should be able to complete the square on each term, right? So you notice for the x's, right, half of 8 is 4, and 4 squared is 16, right? So that's what I want to do, right? I want to add 16 here. But how are we going to balance that out? Do you want to add 16 on the other side? And that'll be incorrect. Because if you think about it, we're not really adding 16 here, right? Because this is in parentheses. Notice what's out here. It's a negative. We're really subtracting 16. So we want to subtract 16 from the right side. If you look at the y terms, right, half of 10 is 5. 5 squared is 25, so let's add 25 in there. But you notice we're not really adding 25, right? So if you look at the others, if you look in front of the parentheses, there's a 4 out front, right? So we're not really adding 25. We're really adding 25 times 4, which is 100. Right, so that's what we want to add on the other side here, right? We want to add 100, right? That is going to balance out these equations. So what do we notice happens now? Okay, well, remember, the whole point of doing this is to get these into perfect trinomials, right? So we got this negative. We know that this is going to be x minus 4 squared, right? This 4 should stay out here. This is going to be y minus 5 squared. Notice what happens on the other side of this equal sign, though. Negative 88 minus 16 is negative 104, plus 100 gives us negative 4 here. Now, we know that we should get a 1 on this side, right? So here's where you're going to be really careful, right? What are we going to do to each of these terms? We're going to divide each term by a negative 4. And notice, once we do so, look what happens to the signs. These negatives actually cancel out. Okay, so we end up with x minus 4 squared over 4 minus y minus 5 squared over 1 is equal to 1. And this is the so-called standard form of this hyperbola. Now you notice that the x term is first, or positive, and the y term is negative. Okay? So where does the center, right? What is the center of this hyperbola? The center is going to be positive 4, positive 5. And we get that from this number here and this number here, right? Okay. Similarly, a squared is equal to 4, right? So a is equal to 2. B squared is equal to 1, so b is just going to equal 1 as well. Okay, c squared, right? C squared is a squared plus b squared. So c squared is going to equal 5. So that means that c is the square root of 5. All right, so now once again, we do not necessarily need to sketch this guy. Yeah, but we'll do a rough sketch just so that we don't make any silly mistakes here, right? So the one thing to remember though is this is a so-called shifted hyperbola, right? Okay. All right, so the center is going to be at 4, 5, which is in quadrant 1, right? So the way that I'm going to draw this graph then is just I'm going to try to focus just on quadrant 1 here, okay? So we want to go 4 units to the right. We want to go 5 units up. Okay? So the center is here now, okay? So what about the major axis, right? The major transverse axis. In this case, it's going to be horizontal because the x term is positive, right? So in order to draw these hyperbola, right, we know that the hyperbola are going to open left to right. And so first thing we want to do is get our box. Okay, so from the center now, right, not from 0, 0, but from the center, we want to go 2 units to the left and 2 units to the right, right, because A is equal to 2. We also want to go 1 unit up and 1 unit down, right, so a little bit smaller box here, a little bit smaller box. And there we go, right, and remember, we need the box because we need the asymptotes, right? The asymptotes go through the opposite corners of the box. They also go through the center. Okay? Sorry, I missed the center there, right? But these are going to be our asymptotes. And we know then that the actual hyperbola, right, are going to open left to right. They're going to follow the asymptotes, go through each vertex here. Okay? So we're going to get a little something like this. Okay, so that graph in blue are going to be the hyperbola. All right, so now the question asks us to get the foci, okay? So how are we going to determine where the foci are? So remember, the center is at 4, 5, right? This is the center right here, okay? Notice what is the value of C? The value of C is radical 5, right? So that means the foci, right? And hope maybe we can use the graph to help, right? The foci should be radical 5 units away on the right and also radical 5 units away on the left. Okay. So what are the coordinates of the foci going to be? It's going to be 4 plus and minus radical 5. Okay. So these are the two x values, right? We're going to go 4 and the radical 5 units more that way. And we're going to go 4, but then we have to subtract radical 5 from that. Okay. And what do you notice about each y coordinate here, right? The y value stays the same. Okay? So 4 plus radical 5, comma 5, and 4 minus radical 5, comma 5. What about the asymptotes? All right, so the asymptotes get a little bit tricky here, right? First thing we want to do is we want to get the slopes, right? Remember, the slopes of the asymptotes, in this case, right, notice we went 1 unit up and 2 units to the right. Okay? So what are the slopes of each of these asymptotes going to be, right? The slopes are going to be plus or minus 1/2 x. Just 1/2, right? Now, I'm not writing the equation yet, right? But the slope of this green line is going to be a positive 1/2, and the slope of this green line is going to be negative 1/2. Okay. Now, how are we going to write the equation, though? Right? Well, the good thing about this is we actually know a point that these lines go through, right? And that point is exactly the center. Okay. Okay. So let's try to rewrite this. Okay. We know the slopes, right? So the slopes are going to be plus and minus 1/2. We also know the center, right? The center, which is a point that these lines go through, is 4, 5, right? So then we can just use a point slope formula and write the equation of each line, right? So y minus 5 is going to equal positive 1/2 x minus 4. And then we'll solve this for y next. But what is the other equation? The other equation of the other asymptote is y minus 5 equals negative 1/2 x minus 4. Yeah. And once again, these two, we just got these using the point slope formula. Okay. Now, I mean, I guess you could maybe leave your answer like this, okay? But, we should solve for y here. Okay, so let's go ahead and do that, right? So we'll get y minus 5 equals 1/2 x minus 2 when we distribute the 1/2 here. Finally, when we add the 5 to both sides, right, we'll add the 5 here. We get y equals 1/2 x plus 3. And similarly for the other asymptote, we'll distribute through the 1/2. Notice in this case we get a negative 1/2 x plus 2. And when we add the 5 to the other side, we get negative 1/2 x plus 7. So that is going to be the equation of each of these asymptotes, right? Y equals 1 half x plus 3, and y equals negative 1 half x plus 7. So if you look at the graph, right, that's going to be exactly the equation of this line, right? Y equals 1 half x plus 3. Then this line here is going to be y equals negative 1 half x plus 7.